The Docker Bake build tool just went general availability, and I'm excited about what this means for creating reproducible builds and automation that can run anywhere, CI, locally. I love it, really. And in this video, I'm going to break down some of the features, the benefits, and walk through some examples. But first, baking Docker. I mean, I'm more of a smash burger kind of guy, but I suppose I could bake something with Docker. That was good. For over 6 years, Docker has had this little known tool that we could execute with a Docker buildx bake command. It's meant to provide even more customization and flexibility than what we're building with today. But if bake has been around all these years, why isn't everyone using it? To answer that, I'll need to take you back in time to 2018. Docker was on a streak of releases, and it seemed like they were creating new tools every few months, experimenting with various container tools on top of Docker Engine to see what would stick. We had a release of the BuildKit project, and then Bake came out with the release of buildx command. Even us Docker captains were having a hard time keeping up with all the ideas coming out of Docker Inc. But we also started to see Docker depreciate products, causing some of their less popular tools to silently stop receiving updates, so I and others were hesitant to use Bake in any significant way since we weren't really confident in its future. And we were kind of right. At the time, everyone was talking about orchestration, and Docker didn't mention Bake again in a significant way, so we just assumed that it would quietly become a deprecated idea like so many others. Fast forward to today, and Docker recently announced general availability of Docker Bake. They did this as a signal to us in the community that after years of development and heavy use internally, they're ready to fully support Bake in the community. And in fact, they're so committed to this that they've announced that they have a plan to change Compose to use Bake in the background for all of its builds in a future release. So now that I know I can trust in a future for Bake, why do I care? What can it do for me today? Well, at its core, Bake is a simple command that gets its instructions from a file formatted in JSON, Compose, or my preference HCL. Yes, that's the file format we use with Terraform. Bake acts as a kind of BuildKit native makefile. It provides a more structured way to configure builds. It still uses Docker files as the detailed instructions, and you'll probably have more stages in your Docker files if you go fancy with it. But it replaces long, complex build commands and build scripts with a more advanced and appropriate tool. Bake is a superset of Docker build and Compose builds, but it makes those things even easier. Here's a partial list of things that Bake can do for you. It can improve build speeds by letting BuildKit automate the caches and parallelism. It can import and export files outside the Docker context for building images. More options for adding variables to your builds. Security entitlements for allowing potentially unsafe actions on the build machines. Add SBOMs and provenance attestations to images. Tag an image with multiple names and registries and push them all at once. Speed up builds with a single context transfer for multiple builds in the same image. Build for multiple architectures concurrently. Push to registries automatically after builds are finished. Set multiple stages if you want to build multiple images from the same Docker. Isolate your build settings from your Compose settings. Build a set of images in a mono repo concurrently all at once. Build images remotely with only a GitHub URL. Build images that export a binary out of the image into the host system automatically. This is good for all the Go and Rust binaries you want to make available for download. Use variables, expressions, and simple Golang ctie functions in the Bake file itself. Use matrix strategies, similar to GitHub action matrices, for building multiple images from the same Docker file by setting different parameters. And do all of that in a single command. But enough talking, let's get into some examples. Hey, before we get to my examples, I want to thank today's sponsor, me. I've been making Docker, Kubernetes, and DevOps content since 2017, and I welcome you to my community of cloud-native DevOps engineers. You can join my 20,000 user Discord server. You can sign up for my low traffic newsletter, buy one of my courses with a coupon, listen to my podcast while you're walking the dog or cat or llama, or become a member here on YouTube and get exclusive perks. If you're enjoying this video, please like and subscribe. This channel is heavily supported by sponsors, and likes and subs are how I show them it's worth it to sponsor a video. Thanks for watching. All right, first up, let's compare a build command, the traditional way with the Docker build, to what the HCL, which is my preferred format, looks like. In this example, we've got a standard Docker build command, and you can see that I'm using multiple tags for different images. In fact, I'm using a third one to tag it in a third way to send to a different registry. I'm adding a label, I'm adding a build argument, I'm setting no cache, and I'm building for multiple platforms. Let's just look at what the HCL equivalent of that would look like. And the standard file naming for the HCL file is docker-bake.hcl. If you do that, just like the standard compose file names, you won't have to specify or hard code the file name when you run the command. So let's look at the difference here. You'll see a new object type called target. And the target is essentially the one thing that you can run in the command. And at the command line, just like with Docker Compose, where you can do a Docker Compose build and then list off the services that you want to build. In this case, we can also do a Docker buildx bake and then the list of targets we want to build. And that target can be this actual build. So this is really looking at a Docker file and it's going to build that Docker image. So there's not much different here, right? This is pretty basic, but this is a little more structured. And this is a convention where we have this file name here. So I automatically know if I see this file that it's probably the right way to build the image. With compose files, you never really know. That compose file might be for local dev. It might be usable in CI or production, but it's often for local dev. So you're going to need to look at that compose file, figure out if it's good for building. With an HCL Docker bake file, we know it's only got one purpose, and that's to build. So this is the simplest form, really. So for my second example, let's look at a compose file and how Bake treats that. In this case, we're going to use the voting app, which is 3 different services that are in a mono repo. So it's going to build all 3 of them, or it could. If you see my voting examples in my courses and other videos, you are familiar with this. And you can see here that I've got the vote service on line 6. I've got the result service on line 21. And then we have the worker service on line 37. One thing you'll notice about compose files here, though, is that they are focused on the container. The build part of it is really just a subset. Here on line 7, the only line that Bake will ever care about is anything below the build subset here. So this array inside the service is where all the action's at for Bake. But the problem is we're mixing concerns here. So I do like that if you want to start with Bake, just using compose files, it'll work fine, it'll work great. But as you build out your Bake complexity here, you're probably going to want to switch to the HCL format so that you can have a little bit of separation of concerns. Again, this is all really preference, but I like the idea of separating out my build from my local development system, right? Where I have the containers, I have the networks, I have secrets in here, I have volumes, I have all sorts of other stuff in here. And so let's look at the equivalent of that, of how Bake sees that. I can do a Docker buildx bake. I can specify that compose file, and I can do a -- print. And what this gives us back, it kind of looks like the HCL, but this is actually the JSON format. A pretty common thing in Docker and a lot of other tools like Kubernetes is really at the end, everything YAML, HCL, however we want to do it, it's all kind of turning into JSON on its way to the API on the back end. So when we do the -- print, we're getting out that JSON. Now, one thing you'll notice here is we have a new object type of group. This is a cool thing that we don't get with Compose, that we do get with Bake. Bake allows us to group targets together and define groups of builds to do with one command. So we have the 3 services as before, just the standard result, voting, and workers. And in the JSON format, they're sort of shown as all targets, right? And then we didn't really specify a lot of build details, so they're all going to be pretty basic here. What the context is the directory, the subdirectory that they're all in, and of course the Docker file. But there's a convention here in Bake where if a target or a group is named default, like you see here on this line, then that will be the default thing run when you just type a docker buildx bake. Of course, you can always specify a specific target by typing in docker buildx bake result, and that would build just this image from that context. But if I just typed docker buildx bake right now and specified that Docker compose file, it would build all three of those images. And that's very similar to what you would do if you just typed a Docker compose build. And in fact, pretty soon, compose will use this on the back end and it'll be identical. But why do you think I'm specifying the file here? And that's because bake has something else built in. Now, you know in compose, when you use compose overrides or other additional files with compose, you can specify multiple files of the command line, and compose has this whole looking for different files. One of them in particular is the docker-compose.override.yaml. That allows you to squish all the files together at runtime when you do a build, and it'll merge all those things together. buildx bake has the same idea. So it will take anything it finds, the compose files, the bake files, it will merge them all together, and it has a series of rules of how it figures out the end result. And the general rule here is that the HCL files win if there's a conflict. If there's the same settings set in both the compose and HCL, it will defer to the HCL version over compose. But if I just remove this and I do the -- print again, one of the things you'll see is it lists that it's reading multiple files. So I do have a Docker bake in here, and it's including that. And it doesn't really change anything because, as you can see, Docker bake, as you can see in this one, it's pretty basic. It has one additional thing, though. It has an additional group that if I used that one, it would only build 2 of the targets. Maybe for certain situations, I would need that. I would only want to build 2 of the apps. And so if I do a docker buildx bake, and then I specify backend, that would then only build the 2 images. And you can see that it only has the worker and result as output. All right, for this next example, we're going to be using the Wordsmith app, which is, again, another mono repo. It has 2 containers and 2 subdirectories, different apps. And this is a simple compose file, right? This is like maybe a typical compose file that you would use locally for just development. And in this case, we are doing simple development, but our CI is more complex. So if we look at our Docker file real quick, we can see that we have multiple stages. So we have the standard build stage here in this Java app, and then we have a separate stage for doing a scan with Trivy, and then we have a final stage for production. And so let's look at how we would do that in a bake file. In this bake file, which I actually have a fix me for, we're going to define different parts of the CI process as different targets with different settings. So in this case, the default one that you would just type docker buildx bake and it would run this target is considered a release. So like for any particular release that you might have, it's going to tag it with 1 or more image names, which you can actually do advanced stuff here where I can use Golang functions here or environment variables that would set my tags at the end of this image name, which I don't have here. But the one thing here that is different is the output is to the registry. So when there's an output of BuildKit, by default, it keeps them in the cache. And options include exporting it to the local file system or loading it inside of Docker's image cache itself, or pushing it to a registry, or not doing anything at all. Basically just leaving it in the BuildKit cache. So in this case, we're saying I want to send it to the registry, and the registry is defined in the tag names, and then I want to build 2 platforms. Now, when I want to go to production with this image and I want a more stable official image, we're going to call it different tags. It's going to inherit the default target so that I don't have to repeat myself here. This is one of the nice things about this file format is that you can get it very lean with using global variables and inheriting other targets. And then I want to include the attestations for SBOMs and provenance information inside the manifest of this Docker image. And then if I just want to scan the image with Trivy inside a Docker file stage, I will target that stage. That's what this target here. It's a little confusing when there's two target names, but that's what this target name will do is it'll tell the BuildKit builder which Docker file stage to scan. I kind of wish that this wasn't called target here. It's just called stage. But the problem is in all the Docker commands and everywhere else, we do -- target. So that naming is consistent. It's just unfortunate that it's overloaded here with two different names. And then the output for this one is cache only, which means that it will just scan the image and then do nothing with it. It's not going to send it to registry. It's not going to put it in an export to Docker's image cache, nothing like that. And for our final image, we're going to get even more advanced. So in this case, we're using a Golang binary. We're building that. And let's look at the Docker file for a second so we understand some of the basics. We've got some arguments here. We're building for a specific platform, whichever one we happen to be on. And we're doing some mounts, right? We're mounting files in here rather than copying them in. And then down here, we have an actual compilation stage where we're going to mount more caching for Go to improve the build speed. And then we actually have a test image. And then we have a linter image where we scan. And then we have a stage just to build this binary so that we can take it out of the image in a little bit. I'll show you how that works and when we get inside the bake file. And then we have this example that is the final production image. It's more or less the same thing as this, except for it has an entry point. Now with all of that, let's go look at the bake file for our final example. So we have a default target here, and this is going to just build the standard image. It's targeting that stage. It's going to have arguments. And we come to the matrix option, which is a little bit advanced, but it is very similar to what you would do in a GitHub action matrix, which allows you to give an array of values that will basically repeat. It'll do the same build or the same action in GitHub Actions over and over once for each value in the array. And in this case, what we're doing is we're saying we're essentially going to build for release or for debug, and we're going to change the name of the tag, which is right here, with a variable that we define here. And you can start to see that some of the complexity we can include in here, where we're saying, if this is released, then name or tag the image bake me latest, otherwise call it a dev image. Next, we have the attestations again, and this time we're actually building for 3 platforms. All right, and as we go down, we've got other targets here that will target different stages in the Docker file, one for test, one for lint. You'll notice here that neither one of these is getting exported to anywhere else. And the next one here is the target bin, which will target the stage in our Docker file. That's the bin stage. What that's going to do is it's changing the output, which means it's not going to take the image and put it into Docker. It's going to take everything that's in that image, which in this case is only a single file, and it's going to output it to the local file system on the host of the builder, and it's going to put it in a subdirectory of build/bin. That's important when you're doing something like GitHub Actions, where you're building an app that you maybe want to load up into the downloadable area of a GitHub repository. So you're going to first build your image, it'll automatically export the binary, and then you would use a different step in your GitHub action to push that binary up into GitHub. This saves you the effort of maybe having to extract or copy the binary out in a separate command before you would then upload it into GitHub. By the way, a lot of this stuff still exists in BuildKit for standard build commands with Docker, but here we don't have to have all that complexity in a single command. And this next one is a cross-platform where it will build it for 3 different platforms, and then it will do the same thing as the previous target because it's inheriting all those. So what you would expect to see is inside that directory, there'd be 3 different copies of that file in different subdirectories. And then we get even more complicated with that, where we're doing a bin all, which means build out all of the 3 image architectures, but also build it for release or debug like we did at the top of this bake file. As you can tell, I'm a big fan of Bake, especially for CI automation. It's a more declarative way to use the best that Docker and BuildKit has to offer for both simple and complex workflows with advanced features in the HCL format that you're not forced to use unless you need them. It also has its own GitHub action, so you can easily move from the Docker build action to the Docker bake action. I'm going to be doing that for a lot of my repos this year. From where I'm sitting, it has tons of advantages and new use cases for image building, but none of the downsides of installing new tools, buying new online services, or learning new file formats or workflows, really. HCL for a lot of us is already familiar because of Terraform. There's already a GitHub action for it. And the bake command has been coming with the Docker engine install on all OSs for many years. So it's already there. On all the systems, you're probably already using Docker. One of my final thoughts about Bake is that to take full advantage of it as a CI workflow engine, you need to lean into Docker file stages. If you like the idea of a Docker buildx bake command being one of the only things you need to run in your CI, then you need to lean into expanding your Docker file with testing stages, maybe CVE scanning stages, etc. Now, I've given demos at conferences where I do that exact thing with multi-stage builds, showing off how multi-stage builds work and the things you can do with them, and trying to shove every possible CI action into a Docker file. But the reality is that Docker file stages aren't a great place for a lot of that stuff to live. A lot of the CI tools actually expect to run from outside the image once it's built. So for bigger teams and projects, it kind of muddies the waters between building your app image and all the other activities you want to happen in CI. Do we want the single file format of Dockerfile to be that single source of truth for everything? And then you end up with a possible 300 or 400 line Dockerfile. Also, CI solutions don't monitor BuildKit well. So to them, this just looks like one big pipeline step rather than the detailed view you would get if each action was its own CI step. I've noticed that over the years as I've tried to make advanced Docker builds, and it's unfortunate that the CI companies don't do more to see into what BuildKit is doing to give you that advanced workflow or pipeline view. This really comes down to preference of where you like to spend your time creating automation. Do you love the Docker file format and want to use it to the max? Great. Use Bake for as much as you can. Do you use GitHub Actions for CI and prefer the YAML job structure of that solution? Great. Do that. I can tell you that if you like the idea of Bake because you can run it anywhere and you can make it declarative and repeatable for more things than just image builds, but maybe you're not a fan of doing it all in Docker files, then you might want to look at more advanced tools like Dagger that allow you to run all these things with the language your app is written in. More on that in another video.